Hello, this is Sadbil. The topic of our discussion in this video tutorial is method of undetermined coefficient. This is the second video on this topic. In our first video, we have learned how to use the method of undetermined coefficient to solve non-homogeneous differential equation. In this video tutorial, we will study some special cases of this method. I will start this video tutorial from this example. So as you can see in this example, we have a non-homogeneous differential equation with a forcing term, and in this case, the forcing term is 3 times e raised to power 2t. So if we try to solve this differential equation using the method of undetermined coefficient to find the particular solution, the first we will try to assume that its solution must take this form a time e raised to power 2t, because the forcing term has the exponential term which is e to the power 2t. But in this special example, you will see that this form of the solution will not work. So let me first show you that why it will not work. For example, if I calculate the first derivative of this differential equation, I will get 2a e raised to power 2t. Now, if I calculate the second order derivative, then y double prime of t, which will be is equal to 4a times e raised to power 2t. Now, if I assume this is the equation number 1 and plug both the first and second order derivative, I will get 4a e raised to power 2t minus 5 times y prime, so it means 10a e raised to power 2t, and then 6 times a, this is a 6a e raised to power 2t, which is equal to then 3 e raised to power 2t. And if you simplify, you can get the left hand side is equal to 0 and the right hand side is e raised to power 2t. So now this is the problem. We cannot determine a because the left hand side become 0. Now first let me give you the reason why the left hand side becomes 0. So as you can see, the auxiliary equation of this differential equation is 5m square minus 5m plus 6 is equal to 0. And if you solve this equation, you get 2 root 2 comma 3. And you know then e raised to power 2t and e raised to power 3t, this set is a fundamental solution set, or this set form a fundamental solution set. And the solution we are trying to assume, the particular solution, is belong to the fundamental set. So fundamental set give us the solution of homogeneous part of the differential equation. So since our solution, our particular solution which we are assuming is what is the part of the fundamental set of solution that was making the left hand side is equal to 0. So it means we have to reform this set solution. So we need to take some different form of that solution, because e raised to power 2t a time a constant will not work, because that is the part of the fundamental set of solution. So in order to resolve this issue, you can assume that y of t will take this form. We will multiply t e raised to power 2t. Why we multiply t? Because we know that the Wronxian of t time e raised to power 2t and e raised to power 2t, this Wronxian is non-zero. And is also, if I calculate the Wronxian with e to the power 2t e raised to power 3t, that will also be non-zero. Since the Wronxian is non-zero, so this solution which also will be independent from the two other particular solution. So now let's see that if this solution will work for a differential equation. So in order to make it work, we need to calculate y prime of t, which is a e raised to power 2t plus 2at e raised to power 2t. And then we need to calculate y double prime of t, which is now 2a e raised to power 2t, and then is going to be 2a e raised to power 2t plus 4a t e raised to power 2t. If I plug everything into equation number 1, this will implies this is a 4a e raised to power 2t plus 4a t e raised to power 2t, and then minus 5 times y prime. So 5 times a e raised to power 2t, that will be now 10 a t e raised to power 2t, and then plus y 6 times y of t, which is 6a t e raised to power 2t. Now you will see that few things will cancel out. For example, this, and that. This is a plus 10 and minus 10, and we also know that this is equal to 3 e raised to power 2t, and this plus that is a negative a. Therefore, negative a is equal to 3. This implies a is equal to negative 3. So now we have the values of a. We can write the particular solution of this differential equation. Y of t is equal to minus 3 t e raised to power 2t. So we was able to determine this coefficient, and this is our particular solution of the differential equation y double prime minus 5 times y prime plus 6 y is equal to 3 e to the power 2t. So if this form of the solution does not work, we just multiply it by t and hope that will work. Now I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. So I have one more special case in this case, and this special example is y double prime minus 4y prime plus 4y is equal to 3 e to the power 2t. Why it is a special case, which is special than even the previous example? If you consider this solution a e raised to power 2t, this will fail, and as well this solution will also fail. You can check, they both will fail, but I will give you the reason why they will fail. Again, the same thing. This is a m square minus 4m plus y is equal to 0. That is the auxiliary equation of the homogeneous part of the differential equation. And it has a double root. So since it is 2 root is repeated, it means the fundamental set of solution is t times e to the power 2t e to the power 2t. So it means this solution and that solution, they both are going to fail. In this situation, when both your solution will fail, you have to assume a different form of the solution, and that's this time it will be e square e raised to power 2. And this is the only special case. This solution will never fail. If I have to assume you the solution, it will never fail because all the independent solution, fundamental set of solution of this differential equation, because of it is order, there are only 2, and none of this has a t square. None of them even cannot have even a t square. So this will never fail. So this will be your last case where you will not have failure by choosing the form of your particular solution. Now let's find out A by calculating y prime of t first and then y double prime of t. So this is a 2a t e raised to power 2t plus 2a t square e raised to power 2t. That is your first derivative. Second derivative is going to be a little bit more challenging. It's going to be a 2a e raised to power 2t plus 4a e raised to power 2t, and there is a t also. And now the second term, which is a 4a t e raised to power 2t, and then plus 4a t square e raised to power 2t. Now let's plug everything into equation number 1. So 1 implies 2a e raised to power 2t. We can combine these two. It's going to be 8a t e raised to power 2t, and then this is a 4a t square e raised to power 2t, and then minus 4 times y prime. So if I minus 4, then it will be 8 t a t e raised to power 2t, and then again minus 8 a t square e raised to power 2t, and then plus 4 times y of t. So 4a t square e raised to power 2t. Everything is equal to 3 e raised to power 2t. And you will see that magically all the term with the t and t square, they will cancel. They must cancel out because this is how we choose that solution. So this gives you that 2a is equal to 3. This implies a is equal to 3 divided by 2. So now we have the value of a. We can write down the general solution. That the general solution will be y of t 3 half t square e to the power 2t. And this is our particular solution of the non-homogeneous differential equation. Here I have one more quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. This is the end of this video tutorial. Thank you very much for watching. I will see you in the next video. Bye for now.